Hello Internet, and welcome to Stanford CS193p, developing applications for iOS using Swift UI. I'm Paul Hegarty. I've been teaching this class for 13 or 14 years, and occasionally I will record it and put it up on the internet for all to see so that you can see what we're doing here at Stanford. Unfortunately, this quarter I did not do that. We are back on campus here after the pandemic. I didn't set up all the cameras and all the stuff that's necessary to do that, so I really apologize for that. However, I did record the screen of my laptop. I had to do that because my students, for their assignments 1 and 2, need to follow along with what I'm doing, and that requires them to be able to look back and see the demos. It's good for you too, because you can do the same thing. It's also very good for my keynote slides where I go over some of the concepts of Swift UI, etc. And I also put this AirPod in my ear all quarter, so hopefully the audio and all this will be pretty good. Unfortunately, there are some things that are in real life here that weren't on the screen. For example, this card game that we are developing, I made some actual cards for it, and I use Lego as an analogy quite a bit. You see my Lego helicopter and my infamous bag of Lego there. You will definitely hear about those when you are listening to the demos. And we also have this very beautiful large projection screen right here, and I tended to walk in front of it and gesture at the code, and you will obviously not see my gestures there. And also maybe the fonts, hopefully they're going to be big enough for you to see on a small device, but if not, you might have to go to iPad size or whatever. But I think it's generally going to be pretty good. Now, this is a university course. My students are taking other classes. I'm trying to pour this information into their head 1 week at a time over 10 weeks. And we have a little bit of a systems bent, the way we approach this. We're trying to understand not just how to develop an app for iOS, but how does the Swift UI system work as a whole. So that may be something you are or are not interested in, but whatever interests you about developing for iOS here, you're gonna definitely wanna go to cs193p.stanford.edu. You'll find links to these videos here, of course, but also you're gonna find the homework assignments, which I highly recommend you do to learn this stuff, and also demo code. I only make the students type it in the first few weeks, and after that, I post all the demo code for all the demos that I do in the course. One other thing to be careful of, this is being taught in spring quarter of 2023, and right down the road, as we speak, Apple is giving their WWDC, their Worldwide Developer Conference, and they're probably inventing all kinds of great new Swift UI and iOS things. And some of those changes might shift a little bit out from under what we're teaching in this quarter. So if you're watching this, even late in 2023, but certainly 2024 and beyond, you might have to take a little bit of care to see if some stuff has changed that makes this a little different than what's in the course. Now, this is an intro course, so I don't expect a lot of stuff to change out from under it, but it's something to pay attention to. So that's all I can think of to say. I hope you enjoy watching these videos, and best of luck to you in your life as an iOS developer. Okay, well, welcome then to CS193p. This is like when the pilot says we're going to Cleveland, make sure you're in the right place. This is what we're doing, developing applications for iOS using Swift UI. And I'm only going to spend just like 5 minutes here on slides, and we're going to just dive right in. And that's the way this course is going to be most of the time. I think you learn the best if I just show it to you as opposed to slides. But there are some things where I'm going to have to put some slides to talk about concepts and all that. So what's this course about? Swift UI in particular is what this course is about. Mostly we're going to develop applications for iOS the first 7 or 8 weeks. Towards the end of the quarter, I'm actually going to show you how to use what you've learned in Swift UI to build a Mac OS app or even a Watch app or Apple TV. They're all the same. Swift UI is used for all of them. So what are you going to learn? You know, some things are going to be kind of familiar to you, like object-oriented programming. The programming language is kind of C-like, but really we're hardly going to use object-oriented programming in this class, so that's mostly just kind of experience for you that will help you learn the new stuff. And the new stuff includes a new language, completely new language, functional programming instead of object-oriented programming. How many people here have written some code in a functional programming language? Actually, that's a lot. I mean, over the years, and first time I asked that, 0. Next year, maybe 1 or 2. Now I'm seeing a few of you. So, languages like Haskell and all that stuff, those are functional programming languages. Most of you, I see, have not had that. I'll be walking you through it. I'm not going to assume you know anything about functional programming. You're also going to learn about a different way of user interface programming. How many people have done some user interface programming in a reactive user interface system? About the same number, again, less than a third of you. So I'm going to not assume you know anything about that as well. And then at the end of the quarter, I'm going to talk to you a little bit about object-oriented databases too. And probably the best thing you're going to get out of this class is you're going to see real-life application of all those things you're learning in all your other classes. Okay, just a little bit of all of it. I've listed a bunch of them here, but that's one of the best things about this class, just an integration of all those things. We're going to do all of everything there we will be doing. Prerequisites. Someone asked about this before. The number one prerequisite in this class is some experience writing code, because it's all coding. Okay, all your homework assignments, you got a final project, it's all coding. I'm not going to have quizzes on concepts. You're going to show me that you know how to do it as the quarter goes on. So if you have not written a lot of code in your life, this is going to seem like a lot, even though each assignment is actually not that much code. Some of them, like assignment 1, maybe it's a dozen lines of code, and it kind of ramps up. But even the biggest one you write, which is probably assignment 3, maybe it's 100 lines of code, but it seems like a lot if you haven't written a lot of code. So that's the number one experience. So I put CS106A and B and 107 and then 108, for example. I put those as prerequisites just to make sure that you've at least had some experience, because some people show up to this class, maybe they've only taken CS106A, and it's like that's all the code they've ever written. Okay, maybe in high school they did AP Computer Science or something. This is really to get you along there. Now, I do also want you to have learned some structured programming methodology, like object-oriented programming. Even though we're not going to be doing object-oriented programming here, at least when I teach you functional programming, you'll have the idea, oh, yeah, there's like a structure. There's, classes and inheritance and instances that you have in object-oriented programming. Functional programming has a lot of things too that are like that, conceptual things. You see what I mean? And so I want you to have had that experience. That's why 107, 108 is a great prerequisite for this class, because object-oriented programming, like CS43, which I believe is functional programming, that's a fantastic prerequisite for this class, but not many people have it. Another kind of pretty hard prerequisite is that I hope you have already learned more than one language, like Python and Java, or C++ and some other language, just so that you're not learning a new language in here. It's the first time you've ever seen a second language. Every time you learn a new language, you start to see what's common to every language and what's different in every language. And that there's a learning curve there, right? It gets steeper. And the more language you learn, the more it flattens out, where it's just less work to learn a new language. If this is your second language ever you're learning, you're on the steep part of the curve, right? If it's the third or fourth, now you're starting to flatten out a little bit. That's another one I put up on prerequisites. And all of these things are things that the more of this you have, the easier this class is going to be. And the less of this you have, the more of a challenge it's all going to be. How does the course work? Mechanically, how does it work? Well, number one thing I'm listing here is ed discussion on Canvas. Do not be shy if you have a question, you're doing your homework, whatever, about hitting this. In lecture, it's mostly going to be demos. I'm going to be walking you through code. And it says here, lots and lots within an ever-growing narrative context. Okay, what do I mean by an ever-growing narrative context? Well, I'm going to talk about the narrative way of learning to do a system like SwiftUI versus what I call the vignette way. The narrative way is you learn all the characters and settings of SwiftUI, and some plot along the way, but mostly you're learning the world, right? Your world building. And we do that by telling the story of developing a SwiftUI application. We're going to spend the first 5 weeks in this class building one big application that has animation and all kinds of stuff in it, but it's going to provide this context that you're very comfortable in as I add new pieces to it, right? You'll know the code, you'll know what I'm doing. And it also, at the end of it, you'll see what it's like to build a big application. It has a lot of stuff in it, versus the vignette way of learning, which is the way a lot of people learn to do SwiftUI programming, which is you're just kind of hacking away and you're like, I need to do drag and drop. How do I do it? And you go on Google and you say search drag and drop, and you go to some website, and there are some fantastic ones out there.
And they'll say, here's a little vignette, how you do drag and drop, right? Here's the functions you call, here's the thing you got to implement. And you just learn that little thing. That's why it's a vignette, right? It doesn't even try to tell you the big story. It's just telling you this one little story about drag and drop or about animating in a certain way. Now, which of these ways is a better way to learn? Clear winner. The answer is the combination of the two. All right. You get the narrative thing from me in the next 9-10 weeks, and then you're going to be totally set up when you go to use vignettes to learn that you'll know the story. You'll know the settings, you'll know the characters. So all the little plots in the vignettes, you'll be ready to go. That's the answer, both. And the vignette stuff on the internet is fantastic. I'm not going to name any one of the people in particular because I don't want to slight the others, but there are some really, really great people online doing fantastic vignette stuff. So that's what you're going to get, is that narrative approach. And that's why we're going to do one big app in the first 5 weeks. Then we're going to do another big app, pretty much the same size app, in only the 3 weeks after that, because you'll know so much more from the 5 weeks. You'll be able to quickly do a similar size app. And then you're going to do a third one, your final project. You're going to get 3 weeks to do that as well. Then I sometimes do slides like this, but not much. Again, concepts mostly only. And there are reading assignments. There's basically one document, the Swift Programming Reference Guide. You are going to read that entire thing. Okay, now that's a lot to consume, and I'm going to give you 4 weeks to do it, and I'm actually going to guide you through it. Read these chapters first and skip over that and come back to it later so that you can consume such a huge amount. I do not expect, I'm not going to give you quizzes on it. I don't expect you to know every single thing. The most important thing I want you to know from reading that is what's in there. Because when you go to do the vignettes, or even later in this course, and you're trying to do something, you'll just know, oh yeah, there was something in there about optionals. What was that again? And then you can go back and find it and read it. If you don't do these reading assignments assiduously and go through read every line of it, you won't really know what's in there. That's what the reading assignment is about. Very important. It's kind of background noise only for the first 4 weeks of the quarter, then you're done for the rest. And then of course there are programming assignments, 6 of them in the first 7 weeks, 1 week each. Most of them are due on Wednesdays. So you'll have one the day after tomorrow that's due next Wednesday. Assignment 2 is the exception. It's going to be due on a Monday, a week and a half later. And then assignment 3 will go another week and a half and be back on Wednesdays for the rest of the time. Assignment 3 in this class is like a midterm. Make sure you schedule yourself to have time to work on assignment 3. It is the first app I'm going to ask you to write on your own. The first 2 assignments, you're going to build on what I'm doing in lecture. Assignment 3, it's like, okay, now show me that you can do an app all by yourself, basically. It's similar to what we do in the first 2 weeks, but it's still, you're on your own. So assignment 3, like a midterm. And then finally, there's this final project. You get 3 weeks to do it. You can pick whatever you want to do it. There'll be a rubric, a very strong rubric that tells you what I'm expecting from you. There'll be a process where you submit a proposal for what you want to do, and I'll just kind of take a look at it and we'll see, does that going to fit the scope of what the rubric is saying? Some ideas are more easily, you can satisfy the rubric more easily with some approaches, some final project ideas than others. But that's, you can start thinking now what you might want to do with the final project. You only get 3 weeks to work on it. I guess only, I mean, 3 weeks in some ways is a long time, but in some ways it's a short time. One thing I'll say about the grading, this class is only pass, no credit. And pass means you've proved to me you can write an iOS app. That means you pass this class. And you do that in 2 ways. One, you pass all the programming assignments, at least show me that you minimally understand what I'm asking you to do in all of those, and you pass the final project. And that's an and. Don't think that you can just ace the weekly assignments and then just blow off the final. Okay. In fact, or the other way around, actually. Don't think you can blow off the program assignments and then just nail your final and you're going to do it. I need to see both things happening. Okay. And the course details document that's on Canvas, read that thing, every line. It describes all the course logistics. I'm just emphasizing a couple of them here, prerequisites and this. I'm not going to go over the rest. Does anyone have any questions about course logistics before I dive into the actual course content here? Okay, great. Let's do it. I saw that almost half of you have done assignment 0. Assignment 0 is to install this application, Xcode. And to hook it up, if we go to Xcode settings up here, you can see that there's a couple of things to set up here. An Apple ID you have to set up, and then a GitHub connection. So you have to do these 2 things. GitHub is how we're going to submit all your assignments, and I'll be showing you how that works in my demos here. And the Apple ID thing is just required by Apple. It doesn't cost anything. Neither of these cost anything. GitHub, you can create your own free account, and the Apple ID, you don't need to pay. You can have a paid developer account with Apple, and you only need it if you're going to use Apple's server technologies like Game Center, or you're going to put an app on the App Store. These things use server space, right, in Apple's servers, and they charge you $99 a year. That is the developer fee. You won't have to do this in this class. I'm not going to ask you to do any of that stuff, so you're good to go. When you run Xcode, this splash screen comes up, and along the right there, you're going to see all the projects we work on this quarter. We're going to start here by creating a new project. I can click here to do it, or I could go up here, File, New, Project, same thing. And it goes here, and you saw this. I'm not going to go over this because it's all covered in assignment 0, but we are going to be building an iOS app. We will be doing a document app later in the quarter. And these other ones, games and all this, I just don't have time to cover all these other kinds of apps. But it gives you an idea of how much there is in SwiftUI. There's just so many different kind of things you can do. Again, I'm just telling you the basic story, right? The characters and the settings of the basic story. So we're going to go iOS app here. It's going to ask us a few questions. Again, I covered this in the tutorial. Here we are. We're ready to build our app. I'm going to show you what app we're going to build over here in a physical version of it here. It's a game. Probably you've heard it called concentration, okay, or memory. The idea is there's these cards. I get these 12 cards up here, and I get to kind of guess. So I'm just going to flip one over. If I can do it here, yeah. And then, oh, I have a pumpkin there, okay? And then I pick another one, like maybe this one. It's a ghost. So I don't have a match here. So now I'm going to pick another one, and when I pick another one, these two will go back face down. All right, but I have to try and remember what was there, right? I had a pumpkin there and a ghost there. So let's see what we have here. I'm just going to flip them up. There's a witch, and what do we got here? We have a cat. So now we have 4 different things. You're going to have to help me here because I'm old, and so my memory is not very good. But what do we got here? Oh, no, a spider. It's not going well here. Bats. You all remembering all this? What do we got down here? Oh, bats. Luckily, that was the last one. So now that I know that the bats are right here, I'm going to pick this bat right here. Woohoo! I got a match. And now the next card that I choose, it's going to take these cards away because I've matched them. And presumably I'll get some points or something for these, right? I'm going to score this in some ways. And part of your homework assignment is you get to decide how to score this. And this scoring can be very sophisticated, not just points for a match or maybe penalty for mismatch, but timing. Like the faster you pick them, the more points you get or something. So anyways, when I pick this next card up here, let's say the cat, leave the cat face up here. And then I said, keep going, right? What do we got here? Cat, I think we had. Here's the pumpkin. I think that was here, etc. So I'm going to use these cards here as props as the quarter goes on to talk about features and stuff we're doing. All right, so everyone understand the game we're building? Now, it's a simple game, but we're going to be building a game with all kinds of animation, the cards moving around and the animating them flipping over and all these kinds of things. And we're going to call this app Memorize. And this team thing, you're going to pick your own team. It'll probably say add team if you haven't done the tutorial yet. And then the organization identifier in the video, I suggest doing this reverse DNS notation here and just put your SUNet ID right here. That's almost certain to uniquely identify you. And we're doing everything in Swift UI here, so it's Swift UI and Swift. And we're not going to be doing these things down here, at least not at the start of the quarter. Next, and now it's going to say, where do you want to put it? I did the assignment 0 tutorial, so there is my repository that I cloned from GitHub. So if you haven't done assignment 0, which is watching this video tutorial, you'll know exactly what I mean by that. And I'm going to put it inside of this cloned repository, which currently has nothing in it. And this is the place I'm going to submit my assignment, because your first assignment, which I'm going to assign on Wednesday, it's actually, I'll make it available today, you can go look at it, is to replicate what I'm doing today and Wednesday, and then add some stuff that shows me you understand what I'm doing. You're going to do this, and I'm going to say create. Creates our first project. Here's our first project. I'm going to make this much larger so we can see what's going on here. I'm also going to hide some of this stuff and bring it back as we talk about it. I'm going to arrange it. And Xcode is huge. It's got so many features. I mean, if you look up here at the menus, look at how many menus a menu. I mean, there's so much stuff. If I went over Xcode today, I wouldn't even finish. We'd still be going Wednesday. So you're going to learn most of what you learn from Xcode by discovery. As you start doing things, you'll start learning. You'll see me doing things as time goes on in here. But I am going to cover a few things, kind of the main things. Let's start right along the top. You see the top here? It has this little like play button, and then it has the name of the app right here. But this is important, this iPhone 14 Pro here. This is a simulator. And you can choose all kinds of different devices. There's more of them than are listed here. I'm going to choose, let's say, iPhone 14. And what this is asking you is, what simulator do you want to run this on when you press play? So let's press play, see what happens here. This is going to launch another app. It's the iPhone Simulator app. See that status line up there, attaching to memorize on iPhone 14? So that status bar will be telling you everything Xcode is doing. Here it is. It's launched it. There it is, the whole hello world, the same thing you were seeing back in Xcode. And what's cool about the simulator is this is actually simulating the whole device. If I swipe up from the bottom here, I can go to do things like settings and stuff like that, which is nice because you might want to run your app with certain settings on, dark mode or whatever, just to see how your app works. Or maybe your app uses mail. There's mail on here on the simulator. You can test that. See what I'm saying? Simulator is great. However, if you all notice here, there's also seems to be one right here, okay? This looks like a phone saying hello world here. And this is called the preview pane. This is previewing whatever is on this side. This view right here, this little hello world thing. And we're going to look at all that code in a second here. And this not only is previewing it, it'll do it in real time. It sometimes will pause, like when you go out of the app and come back. So it's running now in real time. So you see it says hello world. If I go over here to the code and change this to be hello CS193p, you can see it's actually as I type the characters, it's updating it. This is really fantastic. Okay, this is really nice. And even if you make big changes over here, it will mostly keep up with you. Sometimes it'll put up a little X that says, I can't understand what you're saying because you're not finished typing or whatever, but it's really, really an awesome system. So we'll get to that in a second. Over here, this little button in the upper left, this is the navigator. And the navigator can show you your project in lots of different ways. In this way, right here's the leftmost tab, this is the files navigator. It's showing you all the files in your project. Now, when you create a new project, you get these 3 files over there for free. This one called Content View, which is this code you're seeing here that we're going to be looking at in detail today. There's also this other one, Memorize App. See that one? This is your main program. See where it says @main? We'll look at this code a little bit later. It's pretty simple code, as you can see. And then there's this assets thing. This is where you can put assets like video files, sound files, icons, images. Your app icon goes here. You see that thing says app icon there. You can drag it in here. So that's what your assets are, right? Media assets. And that's it. That's all that there is in this project, nothing else. This navigator can also show you things like your source repository. Here's the repository that's over on GitHub, and I can see the remotes in there. There's my main. It can also search. One thing about search, you see it says find. You can also do find and replace up here. It's kind of hidden, but if you click on find, you can change it to be replace. Show me all the errors. If I'm debugging, it'll show me my breakpoints. I can also see all my past builds that I've made, all the errors that came out, whatever. This is the navigator. It's how you navigate. Now, what's interesting is you think, whoa, it's pretty important to have this open as I'm navigating. You almost never have that open. All right. And the reason for that is that along the top, there's a couple of cool things. This is tabs. Anything you open, you can get back to really quickly with tabs. And these tabs will grow as I open more and more files. And even more kind of access is this line. This is the path bar. This is showing you a path to where your cursor is. See the blue line right here? That's actually showing me the full path to it. I'm in my Memorize project. I'm in a Memorize folder. That's where all these files are stored. I'm in this content view. This little icon means it's a Swift file. And I'm in the body far right here, which in fact is where I am. And not only does this show you it, you can use it to jump around. I want to go over to the Memorize app, I want to go back to the content view, etc. So this is what you're going to use to navigate around for your files, not that navigator thing. But the navigator will also pop out when you have an error. For example, you're running your program, array index out of bounds. It's going to pop up there and show you, oh, you got a problem. Then on the right, you saw there was one appear over here. This is the inspector. And this actually inspects or kind of gives you a UI to edit whatever is selected over here. Now, you see this thing when I typed CS193p, it just immediately updated? That's because it's in run mode. See this little live thing down here? You can also put it into select mode. And when you're in select mode, when you click on something in your code, it'll select it. See how it's put a little blue box around it? There. And it also, at the same time, will over here, if you look in the right inspectors, this one, it'll show you all the things you can edit about it, like its color. This is like an editor for it or inspector. Now, why do we have this? Well, a couple of reasons. One, I'm going to teach you how to do it all over here. Okay, you're going to be programmers. You can be working over here. So you might say, why would I ever want to set the color here when I can learn a line of code, which is what this is, to do it? Well, the answer is you might not be a programmer. Maybe you've handed this off to your UI designers and they want to play around a little bit with the alignment of things or whatever, or the colors, or you've sent it to your localizers, people who are localizing it to other languages, and they want to reset this thing right here, and they're not really programmers. So maybe they would muck this around and send it back to you, because watch what happens when I change over here. See color, accent color, let's pick orange. It changed the code. These things are linked. This is always showing what's happening here, and this is always editing what's selected there. Now, again, you guys are programmers, probably not going to have that open very much. This is how you're going to be looking at Xcode the vast majority of the time here. There's another thing at the bottom. Pull it up. Whoop. So down here, we actually have two things. One is your debugger. That's on the left over here. And you're not going to need to do much debugging in this class in the first few weeks. Maybe you'll do print statements to the console, though, and that's right here. You got debugger and your console. One thing that's cool is in your code, if you put a print statement to print out to the console, this will automatically fly up when it sees output coming up there. So that's it. That's the grand tour of the basic parts. I'll show you one other thing, which is hiding this. You see this preview on the right. If you don't want it, if you click here, you can say show editor only, and it will just only show the editor. Or to get it back, you pick canvas. That's what they call this thing. I don't know why they don't say preview window, but canvas. All right. Don't think I have anything else to show you about Xcode, so time to start looking at this code. The first code I'm going to look at is actually down here. See, it says content view previews. This thing that we're building here is called the content view. That's just a generic name, content view. It just made that up because it didn't know we were building a card game, so it didn't know what to call this free struct that it gave us, the hello world thing. It could have just as easily been called hello world view or something like that. But this content view under bar previews is the thing that glues that to this. What is this preview showing? Look, it's showing the content view, this thing up here. This you usually don't have to mess around with. I'm going to show you when you would need to, but I'm actually going to move it down out of the way so it's not bothering us, okay? We don't need to look at it. It has nothing to do with what we're actually working on. And you can do that too if you want. That previous thing is almost always just going to say, make one of these and put it up here. All right, let's start going through this line by line of code. Let's start at the top there, import Swift UI. That's like an include or an import that you would see in other languages. We don't always import Swift UI, believe it or not, because we're going to separate out basically our UI from our back end, from the logic. Like our game, the thing that decides whether two cards are a match and how many points to give is not going to be a UI thing. It's going to be separated out into its own world. Those files will not import Swift UI. They'll import something probably called Foundation, which is like arrays and dictionaries and stuff like that, but it's not going to import Swift UI. But on the flip side, everything that's doing UI has to import Swift UI. There are other things that we might import, like when we do the object-oriented database, we're going to import core data. Core data is the module that has all of the object-oriented database. You'll see that later in the quarter. Now let's look at the guts of what makes our little hello world thing happen over here. You can see the first word is struct. Struct is just a key word in Swift that means this is a structure. Now, all languages pretty much have structs. Now in C, structs just are little things that hold variables. In Swift UI, structs are super important. They are the heart of everything we do in Swift UI, okay? Pretty much everything is a struct. And structs can have variables, of course, in there, but they can also have functions. And when I say that they have variables and functions, some of you are immediately thinking, oh, it's like a class, right? A class in object-oriented programming, that's got variables and functions, but it is most certainly not object-oriented programming. It is not a class. It is just a struct that has variables and functions in it. So there's no inheritance going on here, right? It's not object-oriented programming. Now, there is a keyword called class. That is a class. That is an object-oriented thing. We're barely going to use that keyword in this whole quarter. Second thing there, content view, that is just the name of this type. Okay, we're declaring a type here, a struct type, and it's called content view. And again, it just got picked for us because it doesn't know what we're doing. So it's like, this is the content of your app, so I'll call it content view. We're going to rename that pretty soon, like next week or the week after, to be called something like memorize game view, because that's really what it's going to be eventually. This right here, colon view, might be the most important thing you're going to see today. And this is your entree into understanding this functional programming thing I'm talking about. By the way, sometimes you'll hear this called protocol-oriented programming as well. So what does this mean? Now, I'm going to introduce a little thing I'm going to do to help you know what's really important, which is when I am going to talk about something that's really important, I'm going to write it up on the board here. And you can take a photo of this later or whatever, or it just helps you understand this is important. And so I'm going to write this one down. This is the first one. And I'm going to do quotes here and say, behaves like a something. Okay, this is fundamental to the functional programming. And that's what this colon space view means. It means this struct called content view behaves like a view. Now, I'm emphasizing this so much because behaves means behavior, functionality. This is functional programming, all right? We're really going to focus on the functionality, the behavior, not on the data. People ask me, what's the difference between functional programming and object-oriented programming? Object-oriented programming, really, its roots, and it's evolved some, but its roots are data encapsulation. You've probably heard that phrase, right? Functional programming would never use the word data in its description of what it does. It's more like behavior encapsulation, if anything, but it's much more than that. But it's all about behavior. How do things behave? How do structs behave? So this struct behaves like a view. Well, what is a view? A view is just a rectangular area on screen that draws something and can get events. Just exactly what you would think a view is. And so this content view behaves like a view. If I behave like a view, what do I have to do? Or why is that a good thing or whatever? Well, anytime you behave like something, you have two sides of a coin, right? A double-edged sword, if you want to think about it. One side of the sword is you have a responsibility. If you're going to behave like a view, you've got to do the things a view does. And so there's going to be some thing you have to do or multiple things you have to do to satisfy this claim that you want to behave like your view. For view, incredibly, there's only one thing you have to do, which is to have this variable in your struct. It's called body, var body, and its type is some view, and we're going to talk exactly what that means in a second. And the other side of the double-edged sword is if you satisfy this requirement and do this thing, you get all the things a view knows how to do. And in Swift UI, it's massive. Hundreds of functions, all kinds of functionality built into view. You just instantly get it all. It's a very leveraged kind of way of programming because you only have to do this one little variable, and then all of a sudden you get this massive amount of functionality, like setting your color and all these other things that you're going to see us do in the next few weeks. In fact, we're going to spend the whole quarter, most of what we're going to be doing is exploring what a view can do, and we won't even get halfway through it. That's how much stuff a view can do. Swift UI is all about views, as you can imagine. rectangular areas on screen that are drawing and taking events. Let's take a look at that var body and try to understand what's happening with this var body. Now, it's kind of weird. You're probably okay with what I've selected here. Var is just a keyword, means it's a variable. Body is its name, right? It's the name of the variable. Some view is its type. Let me show you what another variable might look like, and you'll probably be a little more comfortable. How about var I is an int? Var s is a string. This is the syntax for variables. Keyword, the name of the thing, colon, the type. Now don't get confused. This is a different thing. This is behaves like a, this is of this type. Those happen to use the same kind of colon thing, which, the reason they chose that is if this S is of type string, it behaves like a string. Okay, so but it's not the same thing. This is not, string is a struct. Okay, so S is a struct, it's a string. Int is a struct. So you see what I'm saying? View is not a struct. View is a thing you can behave like, okay, called a protocol. So don't get confused there. But that's what those are, and I can have as many of those bars as I want. But this bar down here, a little different. For one thing, it's got this, okay? This little curly brace thing. And so I'm going to write on the board again. Here's something important. So this is computed property. A computed property, the reason it's called that is because this var body, these things, we call them properties. You call them variables. You'll sometimes hear me call them vars because of that keyword var, but they're properties in Swift because it's a property of this struct that it has that variable attached to it. So that's what property means. Computed means this blue part, which is that the value of this variable is not stored somewhere, it's computed. Every time someone asks for the value of body, it runs this code. And that's the value. This code is getting run over and over every single time someone asks for this body. It's computed. It's read-only because it's calculated here, but it's still a var because there might be variables in here that are making it return a different thing every time you call it. This is code. It's going to run, and so it might change. So that's why this is variable, but it's like a read-only variable because you can only compute the value. Computed properties, you're going to see them all over the place in Swift UI. These up here are not computed properties. I guess you'd call them normal properties, okay? Stored properties. There'll be storage in that struct for those things. How about this? Some view, okay? That is an awfully weird type. That's not like string or int or something. It's got some, and then this weird thing, view, which is a behaves like thing. Well, can anyone guess what that means? Some view, that type? No guessers? Okay, so good thing I'm explaining it. It means that the type of this variable has to be any struct in the world as long as it behaves like a view. In other words, some view. Now, which view? Okay, because there's thousands of views in the world. Which one is it? Well, very simple. This sum tells Swift, execute this code, see what it returns, use that. So that's what some view means. It means run this code. This is a computed property. It only works with computed properties like this. It means look in there, see what it returns, and that's it. That's the view to use. So it's doing two things at once. One, it's figuring this out for you, and two, it's making sure that the thing that it returns is some view. Okay, it will give you a big compiler error if it doesn't. I want to try and understand why it is that if you want to behave like a view, your only job is to implement something like that. This var body some view. How does that make sense? Because basically what it's saying is, if you want to behave like a view, you have to variable that returns some other view. Huh, what? Let's use this beautiful Lego that my son built for us today to understand what is going on here. So I have a Lego thing here. It's this set right here. It's called Emergency Vehicles Headquarters. Okay, it's part of the city, Lego City thing. So this will be in your city. And it's got some parts here. It's got the headquarters building here. It's got a nice firefighting helicopter and an ambulance and a police car right here. And it even comes, this is funny, comes with Granny here. And Granny's been doing some barbecuing at the barbecue, but it's under a tree and she's caught the tree on fire. See that fire coming out the top? And this helicopter, firefighting helicopter, come along and shoots water cannon at it. So I don't know who designs these things at Lego. But anyway, that's what we got. So we got this Lego thing right here. We're going to draw an analogy between Lego and the views. Now, the first thing is easy. And I'm going to pull a wall off of this building right here. And this you'll understand easily, right? Everyone's played with Lego, I assume. They're these little bricks, right? Little white bricks. And of course, if you stack the bricks on top of each other to build things, and some might even say that it's a vertical stack of things, okay? So you do that, and now you can definitely see that part of the Lego analogy, right? Is that if you think of Legos as views, then I'm going to be combining together, maybe vertically like a V-stack there. Okay, so that's the kind of the simple part of it, but there's a little more of a complex way of looking at it, which I want you to see the Lego analogy this way, and then it'll all make sense why we have this bar body. Let's consider our helicopter right here. What we're going to do, we're going to take the rotor off right here. So here's my helicopter's rotor. I'm going to say that this is a Lego. We know that those little bricks are Legos, but now I'm going to say this is a Lego. I put it together out of smaller pieces, okay? But once I put it together, now I have a rotor Lego, complex Lego. Same thing here maybe with the landing gear. Take that off. Here's the landing gear of my helicopter. This is a landing gear Lego now that I've put all these pieces together. And the same thing here. This is the airframe Lego, helicopter airframe. Maybe it's made up of other things, tail, thing, cockpit, Lego, whatever. So I'm going to basically build my Legos here out of these more complex Legos that I built. In fact, maybe I'll even V-stack them. Look at this. I'm going to put that there. I'm going to put this on top of here. I just stacked 3 Legos, a rotor Lego, an airframe Lego, and a landing gear Lego to make another Lego. What if this were my content view? You see? So do you see why defining myself as a view, having a variable that returns some other view makes sense? Because if I'm building a helicopter view, I'm going to V-stack 3 other ones that I probably built with other ones. So there's infinite recursion here. I can build arbitrarily complex things. Not just my helicopter, but my whole headquarters. I could build my whole Lego city out of things by just always having my view be built out of other views. And so inside here, we're obviously mostly going to have V stacks and H stacks and grids and things that combine other views to make more complex things. So that's our Lego analogy there. Let's dive in and look at this free one we got that does this and how it does what it does. It's pretty obvious. I'm going to write a couple more things up here, creating instances of structs, named parameters, and also parameter defaults. So I'm going to do all 3 of these here at once. First thing, creating instances of structs. How do we create a struct? Not just a view, but any struct. Super simple. Here's an example of creating a struct, an image struct. Here's an example of creating a struct, a text struct. Both of those structs behave like a view. They're also kind of like Lego bricks. They're in the Swift UI library. They're like building blocks, the base of the most simple kind of views that you can have. And the way you create a struct is you just put its name. So like ours is called content view. So if we were creating a content view, we would say content view, open parentheses, any arguments you need to pass to create that struct, and close parentheses. Really, really straightforward. What's tricky though, what's probably new to almost all of you, is this little beauty right here, okay, system name. So here's image. Image is just a struct, behaves like a view. And here's its argument, globe. System name, it's naming that parameter. It's named. Now, not all parameters have name. This one has no name, but you don't need a name here because a text view, obviously, just give me the text, I'll show it. But here, this could be system name. Maybe it could be the word named. If you say image named and then a string, then it goes over here and looks in that assets place I was showing you before. And it tries to find an image that you brought into your assets named that string. You see? So I can have the same construction here and just have a different name for this parameter called named instead of system name, and now it interprets it differently. And it also means that you can have lots of different combinations of arguments to create structs, right? And we're going to show you later in the quarter how you do that. Basically, how you make it so that one struct can be created with all different kinds of initializing arguments. It's very common. Almost all structs have more than one way to implement them if they have any complexity at all. Even text has some other ways to initialize it where you can give it a number, for example, and tell it to use a formatter to format it. That's how you create a struct, okay? So that's the creating instances of structs. The third thing is parameter defaults. And what parameter defaults is saying is there are other arguments that you could specify here, but you'll take the default value so you don't have to put it. So you're often going to see that. So let me show you that by talking a little bit about VStack. Because eagle-eyed students are saying, well, what about this? That's a struct, right? It's a struct that behaves like a view, in fact. So VStack is no different than any other view. The only thing about VStack is that it takes other Legos and stacks them on top of each other. That's how we're getting this. So if you look at this UI, there are three views here. There's the text view, there's the image view, and there's the VStack that contains both of them. But why does VStack not have open parentheses something? Well, actually, it could. It could be, for example, VStack has alignment as an argument, dot leading. Look what happened. It made the things line up on the leading edge there. Or I could do spacing, 20, something like that. It put more space between the things. So it does have arguments. See, open parentheses, close parentheses, arguments in there. Now you might be thinking, oh, okay, so what you're saying is if I don't have any arguments, then I don't have to do anything. Not true. If you have no arguments, you normally have to do this. And this is legal too. Now, the compiler is running here. It's not complaining. This is everything I've typed, perfectly legal. But what the heck does this mean? What is going on with that right there? Well, I'm going to go back to my Lego here. I'm actually going to open the box. How many people here have not built a Lego thing like this? I'm pretty much everyone, right? If you do, look how it comes. It comes in bags. Can you see on there it says 1? And if I dig in here more, there's some instructions. And then the instructions also have a number. So this is number 2. Find bag number 2. Here it is. Okay, this is the helicopter. I get a bag here. 2. Here's my instructions for 2, how to do it. VStack is kind of like these two things put together, right? It wants a bag of Lego, which is what I've got selected right here. And then it provides the instructions, how to stack them in VStack's case on top of each other. So we're going to talk about this bag of Lego. That is the thing in curly braces. This thing in curly braces is actually a function. Embedded functions like this are everywhere in SwiftUI. It might seem weird now. Get used to it because all code you write is going to have embedded functions everywhere. Guess why? Functional programming. Functions are passed as arguments to other things all the time. It's just a fundamental part of functional programming. And that's what's going on here. This function returns a view. It returns something that behaves like a view. In particular, a bag of Lego. So the bag of Lego is a view. Now, unfortunately, we can't just put it on our thing, okay? We have to open it up and arrange it. So bag of Lego views need to be passed to something like a VStack or a grid or something that can open the bag up and put it in there. But it's still, bag of Lego is still a view. It still gets passed around like a view. It's also kind of got weird syntax for a function because it's like, this is just 2 views, image and text, kind of listed. It's kind of a list, right? And so there's a post-processing step going on here that is taking this list of views, packaging it up into something called a tuple view, T-U-P-L-E view. Tuple is not the word two. Tuple view just means a list of views. It could be any number, not just 2. And so it's making a tuple view. So this is actually a function that returns a tuple view with these 2 things in it, the image and the text. That's what's going on here. That's reality. Tuple view is a bag of Lego view. Never makes sense on its own. It always wants to be passed as an argument, but it doesn't look like this is being passed as an argument to the VStack, but it is, because really this looks like this. Content, colon, and that. That's really what's happening here. The whole thing where we didn't say content and we didn't have the open parentheses, closed parentheses, that's all just to make the code look simpler and nicer and cleaner. But this is really what's happening. VStack is a view that's taking this one argument, which is a function that returns a bag of Lego view that it can arrange. I'll let that sink in. Everybody got that, what's going on there? Now, other people who would teach you Swift UI would probably not tell you any of this. They would just say, oh, when you do a VStack, just put curly brace and a list of views. That's it. And they wouldn't tell you that that's a function and that there's a tuple view going on and all that. And so it's probably fine if you're like, I don't really get that. You can look at it as just my VStack gets a curly brace list of views, and it'll work fine for probably the whole quarter or most of the quarter. Inside this bag of Lego view, we can't do much. We can only really list views. We can have conditionals, if-thens, and we can declare local variables. That's it. We can't do any math. We can't do any other stuff. We just do those three things. And the thing that turns this list into a tuple view is called, I'm going to write this up here, a view builder. So when you hear view builder, they're talking about the thing that turns that list of views into a tuple view. All right, we've kind of mostly understood what's going on with building. I'm going to leave that content there, by the way. You would never do that in your actual code. It's just gross, right? You would go the nice cleaner way. But I'm going to leave it up there for a while. We'll switch it back in a minute. Because I really want to sink in what's going on there. So let's keep talking about things here. Let's talk about these. See these two lines of code, image scale and foreground color? What are those? And padding too. What are these things? We know this is creating a struct, this is creating a struct. What are these things doing? Those are just functions. This is what it looks like to call a function in Swift. Very similar like Java, right? Call a function. Unfortunately, none of them have an argument like system name, but I'm stuck with what they created for me here. But you're going to see a lot of functions do have these parameter names. They can. It's optional if they want them or not. Now, these functions aren't really special in any kind of fundamental way, but it's important to know what they do. We call this kind of function a view modifier, because what it does is you call it on a view, right? Image is a struct that behaves like a view, so it can be called, these functions can be called on it, and these functions can be called on any struct that behaves like a view. It's part of what you get when you say, yeah, I behave like a view. You do what you're required to do, the var body. Now all of a sudden people can call these functions on you, and there's hundreds of them. These things right here, they return a view. You send them to a view, it modifies the view in some way, and then it returns you a new modified view. When we look at this VStack, we thought there was an image in there and a text, but not quite. There's a text, but there's an image that has had its scale modified to be large and its color changed to orange. That's really this view. So there's two views in here, this one and this one, because this one modified it and returned a view, and then we modified that view. And what's great about all views doing all these functions is that we can chain these view modifiers, right? Modify a view, then modify it again, and then keep modifying it over and over. Okay, so that's what's going on here. These things, image scale and foreground color, I can change them, of course, like let's change that image scale to be small. Look how small that got right there. See that? And we already saw that we could change our color in the editor, but we can also change it in code. Notice Xcode helps you a lot. If I type dot and start to type, look, it shows me right here. Oh yeah, I want my green. And it goes to green. Another thing that's important to understand and remember is that VStack is a view. So you can send these things to it. And that's what that padding is at the bottom. Now you're not really noticing it, but there's padding around this. Since it's centered, you can't see it. What happens if I took this padding and put it around the text? Okay, so I'm going to cut over there, paste. Look, see? That thing kind of moved out of the way because this text got a padding around it. All views do that. But here's the real power of it. What if I sent to vstack.font, which is a view modifier, and we'll go, these are all the different fonts we can do. Let's say large title. This got large, and this got large. Everything in the VStack got that modifier. So VStacks and HStacks and grids and other things that take bags of Lego, when you do things on them that really don't make sense to do to the whole thing, they pass it off to the things inside. Not only things like font, but also, watch this. Let's take our foreground color, put it out here, and change it. See, they changed both green, both orange. I'm modifying everything inside. So the scoping of these view modifiers matters. Now, what about image scale? That seems like it's an image only thing, right? Doesn't make sense to do on a text. But if I take this out of here, put it down here, still works. This still got small. Now, that's just because image scale was applied to the text and the text ignored it because it's not an image. So that provides a lot of flexibility to be able to put these things on the outside and have them only apply to the things on the inside that really care. Hopefully this helped you understand really all there is to know about building views. We can create the views right here and here. We can modify them with these modifiers. We can use the VStacks and list views to combine things. And we return it all from our var body, and that's what makes us into a helicopter view or whatever. And we're just going to do this more and more, building bigger and bigger things as we build our app. So let's start building our app there. What do we need to build that app? Well, we need cards. Okay, we got to have those cards. Here's a card right here. Obviously, to build a card, I'm going to need a rectangle. So let's get a rectangle on screen. I'm just going to go in here and get rid of some of this stuff. We don't need a globe. We do want some text, actually, but we just want the text to like have an emoji on it or something. One thing you're going to find out in this class, we love emoji in this class, okay? We are going to use so much emoji in this class. In fact, the second app we're going to build is called emoji art, all right? So emoji is our favorite thing. And we're going to but you can see why. Look at all these cute emoji. Let's go with a ghost. Put a ghost in there. By the way, I just went up here to this edit menu. All Mac apps, usually in the edit menu, the last one is this emoji and symbols. You can go pick things. So I put that there. I don't really need this padding around here. I am going to put the padding back on the outside of my body. Usually the top level thing in your app, the content view or whatever, you want padding around the outside in case it starts getting big. You want it to not smash into the edges, right? The edges of your device. So we usually leave the padding around the outside. I'm going to do this font large title. I'm going to put this just on the text. No reason to apply that to everything. And now I'm going to put my rectangle in here. Let's just type it in. We're going to use rectangle. There you go. I got a rectangle. So rectangle is, of course, a struct that behaves like a view. It is also something that behaves like a shape. So shape is another thing in Swift UI. And rectangle is one. Another shape is circle. There's also rounded rectangle, which is kind of nice for a card. Rounded rectangle. Now, rounded rectangle needs an argument. For example, its corner radius, 12 points or so. This has created this little bit rounded rectangle. So we definitely need that for our card. But our card, the emoji is on the front. It's not down below like this. So we need to put it on the front. And that's really easy to do. We're just going to change our V stack into a Z stack. Z is this direction, right, towards the user is Z. V was up and down. H, by the way, is side to side. So in V. So look, our little guy, he appeared on the front. But that doesn't actually look like a card either. The card is white. The back of it, it might be orange, but the front is white with it on there. So we actually want that to be white, but I can't really just say something like foreground color dot white. That's not really doing it either, because now I can't see the card, right? It just blends in the background. So what I'm going to do here is I'm going to use a shape thing called stroke border. Stroke border takes an argument here, line width. I'll do 10 to start so you can see. That's making a thick border. So now this looks a little more like our card. Ours don't really have a border. We kind of need it because our background might be white. So we have to be careful there. And so this is looking good. And notice I also typed this right here, okay, as opposed to right here. And both of those are okay. I tend to like to put them here on the next line as opposed to on the same line like this, unless this is the only modifier and it's very tightly coupled to what I'm doing. So I might be okay with the font on the text one like that. It's a style, programming style thing. By the way, the stroke border can have lots of other arguments. For example, it could have style. So I'm just showing this to show the kind of amount of things that we could have. We could make that thing be dashed, dash line. Maybe that's 10, and then 10 on, and then 2 off, something like that. I only did this to show that complicated things are possible. Now, I'm not going to ask you to do these kind of complicated things. It takes a while to learn all these things. So we'll be doing mostly simple and straightforward things like just line width here. And we don't need line width 10, maybe line width 2 is enough. Yeah, that's thick enough to kind of give us an idea of the card. Now, we might think, okay, good, our card looks good. But actually, this card does not look good, and I'm going to show you why. Right here in our preview, you see this little button down here, variants. Click on that, and you can see that there's color scheme variants, orientation variants, and dynamic type variants. So these are the 3 major ways that devices differ. This one is dark mode and light mode. How many people have done dark mode on their phones? So everybody knows that. So you want to be able to look at your UI both in dark mode and light mode. Make sure it looks good in both. Orientation is landscape and portrait, side by side, so you can see what they look like. So let's look at the dark mode, light mode. Here it is. There they are, side by side. Our cards look terrible in dark mode. Okay, they really want to have a white background in dark mode too. So how can we do that? Unfortunately, there's no way to both stroke and fill a shape. You can only either stroke it or fill it. By the way, get this there. So how are we going to do this then? We need a kind of a white background. Well, we're just going to create another rectangle behind it. Okay, so I'm going to go here and copy and paste this, create a rectangle. And this one's going to be foreground color white. I could also say dot fill white. That's another way of saying this. And now we have it behind. And we got a color. Let's get rid of our image scale in there. We can go back to live mode, for example. And we could also do it with landscape. Let's do it with landscape just while we're here. Let's go over here to our orientation variants. You can see in landscape, it's kind of hard to see. We could zoom in there a little bit. It looks okay. Looks okay there. So mostly those variant views are just to kind of get an idea if it looks right. When you actually come to build your app, you're going to switch this whole thing into dark mode, and you do that with this switch. Color scheme, dark mode. And now my live view is in dark mode, so I'm going to make sure this looks how I want. I'm basically really debugging it. So the variant view is just to get you an idea, and then this view is to really pick what you want, okay, whether it's orientation. And dynamic type, by the way, is you want your app to look good if the user is like me, getting old, and needs the font to be really big to be able to see. There's a slider in settings on your phone that lets you set that, and you want your app to look good. So the size variance will show your app looking like 10 different font sizes. So we got a card. This looks like a card. It's not very good. It's got a tiny little thing and it's really gigantic. But before we fix any of that, let's make multiple cards. So how are we going to do that? Well, of course we could copy and paste. Maybe we'll just make an H stack. And inside this H stack, we'll put 4 cards. So I'm just going to cut and then go paste, 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 paste. Let's put these in here. Look at that. We have 4 cards, right? This is extremely bad code right here. You would never copy. In fact, anytime you find yourself copying and pasting, you're almost certainly doing it wrong, right? Anytime I do that, copy and paste code, I always stop and say, okay, now what am I really going to do when it's time to really do this right, okay? Because copying and paste is just so error prone, obviously not good. So how do we get out of it? The other thing too is look how long this var body is, how many lines of code is in. I want you to have a goal certainly in this class, but also in your life as a SwiftUI programmer, never have a function or a computed variable like this longer than 20 lines of code, 12 preferably. So I'm going to endeavor when we go through this to never have one with more than 12 lines of code, just to show you it can be done. And there are tools in terms of the syntax of the language to be able to do that. And I'm going to show you one of them right now. And what this one is I want to create a new view. Just like I told you I had the rotor view, it's like I'm going to create my rotor view, which is a card view. Okay, so how do we create a new view? Really easy. I'm just going to scroll down here. This is my content view right here. So I'm just right below my content view. I'm going to say struct card view. It behaves like a view. Well, what happens when it behaves like a view? I got to do var body, which is some view, and it's a computed property. So inside here, I have to put anything. Well, I'm going to put one of these things, of course, dstack. Cut that out of here, paste it in here. Voila, I've just made a new view, a card view that represents one of these cards. And now I can go back and get rid of all this yucky code, just delete it all. And instead, I can say card view, right? Because we know that's how we create a struct, the name of the type, and then the arguments. Our card view needs no arguments to be created. And if I want multiple of them, here I could copy and paste. And of course, I'm going to show you how to do multiple of those without copying and paste, basically a for loop, right? The for loop, by the way, in Swift is essentially a bag of Lego, right? Because it's going to create something multiple times. We're not going to do that right now, though. So that's good. This code looks really good. Both of these bar bodies are really small and really clear what's going on. And I just did that H stack on the fly. I hope everyone was comfortable with that, right? It's just horizontally stacking them, the cards across this way. Now, we eventually want it to be a grid, and we'll get to that on Wednesday, make this into a grid. But for now, we're just going to make this be horizontal. And this is essentially our Lego analogy fulfilled. We created a rotor, and then we made 4 of them, actually. But we fulfilled our kind of analogy of building another view out of other things and then building something out of that, right? So we're kind of going down the road of our analogy. Now, let's see what time we got. Yeah, I think we have time to do one last thing, which is our card view has no arguments, but I can give it an argument. Like, what about this card view being face up or face down? That'd be cool if I could have the card view have an argument whether it's face up or face down. Wouldn't that be cool? No problem. Just go down here. I'm going to say in my struct, var is face up is of type bool. Okay, bool is a struct that's built into Swift. It's true or false or its only values. I've created that, and as soon as I do that, I get an error up there. Missing argument for parameter is face up. Well, if you have a var like this in your struct, it has to have a value. Okay, this is something to understand right off the bat. All structs, every var has to have a value. Now, this var has a value, it's computed. This var has no value, okay? So that's why the creation of it up there is saying, I need to give that thing a value, yeah. Oh, you're like a shill in the audience because I'm going to show you exactly how to do that. I could say var face up equals false. Now, this is not required, you see, because I gave it a default value. This is just a default, though, because I can still go up here to my card view and say, is face up is true. And that changes it. So this is how we do these arguments to the creation of structs and also where that keyword comes from. Remember, like system name to image? This is face up. It's really, really simple. Now that we have is face up, how could we use it inside of our card view to draw our card face down? Well, I told you that the bag of Lego, okay, this thing right here, is allowed to have conditionals, like if then. Well, let's just do it. If it is face up, then we want what we got right here. That looks like a face up card. Else, what does the back of the card look like? That's this thing. It's just a big rectangle. So let's put that in there. That's the same rounded rectangle right here. But instead of being white, it's whatever color this thing wants to be. So I'm actually not going to specify the color. And when I don't specify the color on the card view, that orange up there actually percolates all the way down into the card views. You see? When I made this H stack be foreground color orange, it made it the default for everything inside the H stack, including all the way down into the card view. That's why the card views, their backs are orange, and also why they're lying around the outside, because the card view doesn't specify what the background is, and so it's getting the color from above. Does that make sense? We got to stop because time's up. What we're going to do next time is we're going to keep going on all this. We're going to add some more bars in here. We're going to do some more stuff with this face upness or not, and then we'll eventually move this to being a grid instead of just being this way across. Okay, so that's what we're going to do on Wednesday. And then next week, really importantly, I'm not here next Monday. No lecture next Monday. Okay, so on Wednesday we're going to pick up with that thing I was telling you about. The back end and the front end are separated. So we'll start preparing ourselves to have game logic over there for playing our game, and that'll be in a separate space. And then on the Monday after that, we'll hook the two up. We'll have our game playing.